So now our last example is actually a little bit harder. Let me explain why. Normally, a full sine curve looks something like this. We start at 0, we go up, down, down, and in back up. This is our full sine curve. But if you notice, I don't have a full sine curve here. The closest I can get to it is starting here and ending here. So that is actually compared to this piece of the sine curve. So we actually have half of a period. So we'll keep that in mind when we calculate our period. Let's get to it with the regular parts, right? Our amplitude is high minus low divided by 2. That's 2 minus negative 2 divided by 2, which is 2. That's our A. Now if I want to look for my vertical shift, that's my high plus my low divided by 2. 2 plus negative 2 over 2, which is 0. So that means no vertical shift. And you can see that the middle is still here at 0 without doing that work. Now, I can see that normally we start up here, but since we're starting down here, that tells me we reflected across the x-axis. Now, for my period. Since we only have half of a period, my period is going to be double pi minus negative pi, which is 2 times 2 pi, which is 4 pi. So that means 4 pi equals 2 pi over b. And if I solve this, I'll get b is 1/2, just saving some space here. So now let's look at if we moved left or right. So normally, let me get a different color. Normally, this point here is at 3 pi over 2, but now we're at pi. So we know we shifted to the left. Let's see by how much. So my horizontal shift, I can figure out by doing 3 pi over 2 minus pi, which is 3 pi over 2 minus 2 pi over 2, which is pi over 2. So we went left this much. Now I have everything I need in order to find my function. F of x is going to be sine of some stuff. So first, my amplitude is 2. There's no vertical shift. I'm reflecting across the x-axis. My b is 1/2. And I go left pi over 2. So sometimes we can still find the equation even if we only see half of a period graph.